All right, our second problem from section 7.2, we want to find the exact value of the expression secant inverse of 2 square root 3 over 3. So we're going to do some things first to set up this problem in a way that we would like to. So we're going to and originally we would end up saying that we're going to let secant inverse of x be equal to y. So we're going to start with this and then we'll transfer this over to theta. So if we let y equal secant inverse of x, then we know that this also means that x is going to be equal to secant of y, where the absolute value of x is greater than or equal to 0, and y is contained in the interval 0 to pi. And it is not pi over 2. So the setup of this problem gives us this intuition. Now we're going to write this in terms of theta instead. So we're going to let theta be equal to secant inverse of x, where now we get that x is equal to secant of theta. Where now we have that theta is between 0 and pi, and it does not equal pi halves. So we've changed up our problem a little bit here. We used this initial idea that we let y equal to secant inverse of x. We've established our values of x and y. Now we change this over to theta instead. So now we're just dealing with theta and x. So then this means that secant of theta is going to be equal to 2 square root 3 over 3. We also know that secant of theta is the same thing as saying 1 over cosine of theta. So we can also say, or 1 over cosine of theta is equal to 2 square root 3 over 3. And now we're dealing with our trigonometric sign that is much more simple. Now we're just dealing with cosine instead of secant. So if we're just dealing with cosine, this is going to make this problem quite a bit easier. So let's go ahead and simplify cosine as much as possible. So we have 1 over cosine is equal to 2 square root 3 over 3. We want to take the reciprocal of each side now to solve for cosine. This means that cosine is equal to 3 divided by 2 times the square root of 3. So to solve for cosine, once again, all we did was take the reciprocal of both sides. Where cosine of theta is equal to 3 divided by 2 times the square root of 3, but we know that the 3 is the same thing as saying the square root of 3 times the square root of 3. So this means that we can cancel our square roots of 3's, and this simplifies down to just the square root of 3 over 2. So we'll highlight this in blue. So now we're saying that cosine of theta is equal to the square root of 3 over 2. And we know that there are places when cosine of theta is equal to this value. We see it on the unit circle. So using this then, the angle in the interval 0 to pi, where theta is not equal to pi over 2, we have that cosine of theta is equal to the square root of 3 over 2. Just realized I wrote that wrong. So for the angle, or secant inverse of 2 square root 3 over 3. So we want to think about the values between 0 and pi. Now that would give us cosine of theta is equal to the square root of 3 over 2. So we know that cosine is only going to be positive in quadrant 1. Cosine is negative in quadrant 2, so our answer has to be in quadrant 1, where really our options are going to be 0, pi over 6, pi over 4, pi over 3, and pi over 2, where we know it can't be pi over 2, and 0 would just end up giving us a 1. So that only leaves our 3 values in between. We know pi over 4 would give us a square root 2 over 2, and anything that is an integer multiple of 3 for cosine would give us a positive or negative 1/2. So that means the only angle left would end up being pi over 6. So thinking about it in the sense of cosine of theta is equal to the square root of 3 over 2 is easier to think about than trying to decipher your way through secant inverse of 2 times the square root of 3 over 3. So our angle then is going to be pi over 6. So thus we get our final answer, secant inverse of 2 times the square root of 3 divided by 3 is going to be equal to pi over 6. So for a problem like this, rewriting this into easier ways was the key in finding our answer here. All right. So for our third problem from section 7.3, we want to solve the equation 7 secant theta plus 9 is equal to negative 5 for theta between 0 and 2 pi. So we want to solve this equation. And if we want to solve this equation, we're going to be solving it for theta, which we can see is bounded between 0 and 2 pi. So if we want to solve the equation for theta, we need to simplify theta as much down as possible. And we see we have an entire equation here. So let's start by simplifying. We want to simplify down to theta. So if we have 7 secant theta plus 9 is equal to negative 5, let's go ahead and subtract 9 from both sides. This gives us 7 secant theta is equal to negative 14. Then we can divide by 7 on each side. When we do that, we end up getting secant theta is equal to negative 2. So over here, we subtracted 9, and then we divided by 7. So we end up with the secant theta is equal to negative 2. We want to simplify down to theta. So this gives us our final value for theta, which is theta is equal to secant inverse of negative 2. So now that we have this equation for theta, we want to go ahead and try and actually find a value for theta. So let's go ahead and try and rewrite it. So we know now that we're going to get that secant of theta is equal to negative 2. Or secant of theta is the same thing as 1 over cosine of theta, which we're saying is equal to negative 2. Then if we want to solve for cosine of theta, just like before, we want to take the reciprocal of both sides. And when we do, this gives us cosine of theta is equal to negative 1/2. So once again, now we just have a much simpler trigonometric expression for us to solve for. So now we have to find the angles of theta that let cosine of theta equal -1/2. So cosine is going to be negative in quadrants 2, my bad, quadrants 2 and quadrant 3. So this means that our values of theta are going to have to be in quadrant 2 and quadrant 3. Then we can also establish that cosine is equal to positive or -1/2 at integer multiples of pi/3. So remember, our integer multiples would be pi/3, 2pi/3, 3pi/3, 4pi/3, things like that. So at the different integer multiples of pi/3 that lands on our unit circle, we know that these are the values where cosine is going to be equal to negative or positive 1/2. And we're looking for -1/2 in quadrants 2 and 3. So we need to find the integer multiples in pi/3 in quadrant 2 and quadrant 3. So these are going to be values in the interval from pi/2 theta, pi/2 and 3pi/2. So if we're thinking about these values, we're thinking of values greater than pi/2 and less than 3pi/2. And these are going to be our integer multiples of pi/3. If we have access to a unit circle, it will be very clear which ones they're going to be. But if we think about just greater than pi/2 in quadrant 3, that first value, that's going to end up being 2pi/3. And then our next value, or our next integer multiple of pi/3 that's going to be in quadrant 3 would end up being 4pi/3. So we've identified what our angles are going to be in order to solve this problem. So we can finally state it then. Cosine of 2pi/3 is equal to cosine of 4pi/3, which is equal to -1/2. So secant so secant inverse here, or in this case, we were just working with secant, so it was secant. So secant of theta is going to be where theta is 2pi/3 is the same thing as when we get secant 4 pi over 3, which is then equal to -2. So our values of theta, in order to solve this problem, would end up being 2 pi over 3 and 4 pi over 3. So quite a bit there. So with section 7.3, a lot of what we did was just taking everything that we had learned so far and then actually using these in a formation of an equation and then solving for that equation. All right, for our fourth problem, which is from section 7.4, we want to establish the identity cosine of theta minus secant of theta is equal to negative sine of theta times tangent of theta. So when we go ahead and establish our identities, we know that one side is our goal and one side is where we start from. It's usually going to be our right-hand side. That's our goal. And our left-hand side is usually where we start. This isn't always the case. Sometimes they may be switched, but it's always easier and better to look for whichever side looks more complicated, then that's where you'll start. Because it's much easier to simplify than it is to expand. So in this case, they look about the same. So this just means that we could pick either one to start from and which one would be our goal. So we'll just stick with the right-hand side as the goal and our left-hand side is where we start. So we're starting with cosine of theta minus secant of theta. Our first thing that we want to do is we just want to start simplifying. We want to start simplifying and rewriting terms. So if we have cosine of theta minus secant of theta, there's no clear way that we can rewrite cosine of theta just yet, but we can rewrite secant of theta, which we know secant of theta is just 1 over cosine of theta. So now we have both terms in terms of cosine. So we can now combine our two terms into just one term. And in order to combine them, we would need to rewrite cosine of theta as cosine squared of theta over cosine of theta minus 1 over cosine of theta. And now we can rewrite this so we just have one term instead of two terms, and this gives us cosine squared of theta minus 1 divided by cosine of theta. So this is what we're left with. All we've done here is we simplified, we rewrote our terms, and then we combined them. Now what we want to do is we want to use an identity we already have. We want to use the identity cosine squared of theta plus sine squared of theta is equal to 1 to replace cosine squared of theta minus 1. So if we have cosine squared of theta minus 1, if we want to rewrite this problem, we can end up with a sine squared theta, but this is going to give us 1 minus cosine squared of theta, and we have cosine squared of theta minus 1. So if we just want to flip those terms, we can now say negative sine squared of theta. This would give us negative 1 plus cosine squared of theta, which we know we can just rewrite as cosine squared of theta minus 1. So we can replace cosine squared of theta minus 1 with a negative sine squared. So we replace cosine squared theta minus 1 with negative sine squared of theta to get negative sine squared of theta divided by cosine of theta. And remember, our goal is to get negative sine of theta times tangent of theta. We do have a negative sine theta, we just have a negative sine theta squared. So we have also a denominator of cosine of theta, and we know that tangent of theta is equal to sine of theta over cosine of theta. So let's go ahead and split up our sine squared. If we do that, we can pull the negative sine of theta out and leave the positive sine of theta over cosine of theta, which we then see is equal to tangent of theta. And this would give us negative sine of theta times tangent of theta. And that establishes our identity. So we started with cosine of theta minus secant of theta. All we did was wanted to simplify, rewrite our terms as much as possible, combine our terms, use our other identities that we know to, once again, just rewrite, keep rewriting those terms. And so finally, we got to negative sine of theta times tangent.